Welcome to the thesis presentation on scenario-based augmented reality management. My name is Kevin Gallant, and I'm presenting this thesis brief on behalf of the SOBI's MTEI program, which is a Master's in Technology, Entrepreneurship, and Innovation at the SOBI School of Business. So my thesis is about augmented reality. The roots from augmented reality started many years ago, many decades ago, with the advent of virtual reality. One of the newest advances in augmented reality and virtual reality is the Oculus Rift, which was recently acquired by Facebook. We're on the development toolkit of this virtual reality display, and this inspired me to look at smart glasses and other types of visual augmented reality devices that could help achieve a better consumer experience for managers. So where did it all begin? Virtual reality is an educational experience. It allows people to experience places, situation, events which wouldn't otherwise be possible. Examine events in non-real time that would otherwise be too long or too short to see. To change one scale, to control the physics in the situation to help assist comprehension of a certain simulation, to manipulate conceptual representations and provide a sense of motivation. There are many augmented reality applications today which are based on VR systems from Qual Schemes 96, allows us to provide high interactive multi-sensory environments, some sense of immersion, or importantly, presence in the environment, computer-generated environments, and flexible or reprogrammable environments, and we want to make them safe. These are some basic applications that we need to focus. So as managers, we have to deal with the project management for any particular augmented reality project. And I used what's called a traditional fishbone diagram to come up with a work breakdown structure and phases of project management. You know, if you've got some type of concept, you implement it, you launch it. And it involves cost, time, quality, and as an owner, developer, you need to look at all these tasks which affect the quality of the product itself, whether it's construction or and these are all traditional issues that happened um, um, in any type of construction management project. Because we're dealing with augmented reality, it is a form of constructivism, and we have to look at, you know, how does that apply to smart glasses. The bottom left, you see a Recon jet. It's made in Canada. It's launching in 2014, 2015. It's used mainly in sports. So we came up with a comprehensive list of different applications out there of different smart glasses. Sports is actually in third in the list, but most of the applications are business, which involves messaging and email in the glasses, and then films and movies, using it as a capture device to capture images and video. But sports is definitely a large area, and the extension of a smartphone and games is a big area too. We can't forget about healthcare and navigation, like a GPS in the glass. But by far, the business applications outperformed more glass needs than others. So if you look at here, all the different glasses on the left, there's over 20 featured here. And the business and the movie camera, or, you know, video, film, that area is a big part of different types of glasses, from Theer 1 to Vuzix M100. What are the core technologies and competencies in augmented reality scenario-based management? This chart covers basically 4 major areas. The technoware, which is the technology and tools to do it; the humanware, the people skills to do it; and the info where the information required, and the knowledge and the training and the facts to get, and then the organware, the organization that's used to embody the operations to make all this happen. And the humanware side, which deals with three major disciplines: 2D artist, which is the UI and user interface, the 2D parts, the 2D buttons, and then the 3D artist, which is the character modeler and the machines that need to be built in 3D, and the levels in augmented reality, and then the animators, the people that animate the characters and animate the machines in the actual augmented reality experience. So there's two scenarios, manufacturing and tourism. With these two scenarios, they have a lot of common things or common site characteristics. How many people are going to be participating in the event? Type of static models, models that don't animate. For example, a building or a road, or a statue or an extension of a building. What type of mobile devices? Is it a smartphone or Google Glass? Is it a simulation? Are there multiple layers from electrical foundation, building, inside, outside? Is it a first person or third person experience? The site, size of the site. Is it a city block or is it as small as a statue? Type of animation models, the length of the scenarios of the animation and narration. How do you launch the application? Are there paths to follow? What type of experience is it? Is the experience a narrative experience, or is it a game type experience? If you're using a character as a tour guide, safety guide, is there any training components? Are there triggered animations? Is there a map view? Is there buttons or a user interface to select from? So in our case, we use two scenarios. On the left, a manufacturing of a centrifugal pump, and a character, Lord Beaverbrook, on the right. On the left, you can see here, manufacturing shows the buttons from technical to live data that was used to operate the pump in augmented reality. And then we had a launch mechanism for Lord Beaverbrook on the right, QR code. Both of these actually launched with QR codes, which is the image you see in the bottom right that has all these squares. So this is the actual in editor view in Mataio, which was used to create the experiences. You can see the 3D pump with an in-app video in the background and 5 buttons that all were interactive with the QR code launch on bottom right. This is an example of the tourism application with Lord Beaverbrook with the launch of the QR code just below his feet. So what kind of things did we discover and develop? Basically, with tourism, we looked at who in the discovery phase, who was a customer, who was our target user, general public, a tourism guide, city managers, tourism directors, the tourists themselves. In the oil and gas or manufacturing was inspectors, maintenance workers, and engineer employees of the company. They're both exterior applicants. We had tested the applications with 6 and 9 participants. Both were low, simple, very simple applications. One was the oil and gas or manufacturing was training, and the tourism was exploration. The tourism used its full character. Oil and gas did not use a character. It used a 3D pump, centrifugal pump model called FBX, which is an acronym called Film Box. And the tourism required a lot more skills in the humanware to make it work, and double the animation time compared to the oil and gas animation. So the measurement and evaluation we used to design this, we used Mataio for both applications. Narration was required for the tourism with no buttons, and it used one channel of Genio for a mobile channel. It did not have any application in video. Um, we used YouTube, um, um, boardroom, and in the field testing for the tourism. We used QR codes for launch. It wasn't a very good positive experience because of the the animation conversions in the character itself in Bataille. In the manufacturing phase, for the design, we used Bataille Creator. We used 5 buttons with 2 channels, one for the buttons, one for the animation. Design measurement. So each in the design technoware, the Bataille Creator was used to create both scenarios for tourism and the manufacturing or oil and gas scenario. Each one was reviewed with the cinematic and boardroom experience, but the tourism was the only one in the field. CBF stands for Cinematic Boardroom Field Experience. I believe both should have had both validations. Both were launched with QR codes, and the oil and gas definitely was a positive experience. So what about the manager's perspective of all this? When you look at the managers looking at any type of augmented reality project, we had to look at the quality issues. And fishbone augmented reality type approach was used to define the major issues. And fishbone was created from 8 different categories that define the quality issues for the scenario. Normally, this was broken down into 2 different areas: subject matter experts, people who knew about augmented reality, and general managers in the bottom of this fishbone. In the top, there was 4 major categories: keeping it simple, good design, good measurement, and good sensory experiences. On the general manager side, they were more interested in cool factors, engaging, the uses of it, and the training aspects of how people get trained with these devices, with this technology. So if you look at the top and bottom here, both this fishbone diagram was built based on many different diagrams as we interviewed different managers. And as we interviewed managers, we came up with some common minor bones, which are below the major bones, such as in the measurement, maximum minimum distances from the QR code, the calibration, the GPS, global positioning system in the smart glass, and the network connectivity. Can you actually get network connectivity? So all those were part of the measurement side of the subject matter expert experiences. For example, in the training, the subcategories were, define new strategies, define the future of learning, increased efficiency in the workplace. Those were issues with training with general managers. So one of the biggest outcomes of the thesis was CBF. It's an acronym that we came up with for showcasing cinematics of our experiences to get them out there, doing an office or a boardroom experience for testing, and then actually testing it in the field, what we call the field experience. So CBF came together so that all augmented reality managers would make sure that all the developers follow have these three things developed for testing, for usability testing, in the field, in the boardroom, and the cinematic. It's great to have in the field, but if people can't experience it in the office or experience it without the device, it's pretty hard to promote the type of technology that we want to have for the end user. So, conclusion, um, I believe that we came up with the major categories that are quite distinct from traditional project management. We know that augmented reality is a difficult technology to implement in the field. What the devices, the amount of devices out there, and the amount of technologies that are used to convert 3D models into an overlay of information, or 2D models into the overlay of information. And this thesis was able to determine characters were very difficult to implement, whereas a small machine product like a pump was quite relatively easily, and the pump was easy to interact with, and the deployment of augmented reality solutions through MTEI was very efficient, and we gained a lot of experiences from this thesis. And I want to thank Claudia DeFonte, professor at Sobey School of Business, my MBCC applied research staff, and my applied arts staff and NRCI RAP for helping us with a lot of the tools and technology over the last few years. And hopefully people can learn to use augmented reality in future projects. Thank you very much.